In a previous video, we learned that material properties are a major factor when choosing a material for a particular design or product. For example, the glass electrical insulator wouldn't be very good if it wasn't electrically insulating. The knife and sandpaper wouldn't work very well if the material wasn't hard. And the brick wouldn't stand up to construction if it wasn't strong. All of these are key properties of ceramics. Also, the radiator wouldn't work if it couldn't conduct heat. And the wrench needs to be tough. These are all key properties of metals. And the oven mitt and rubber bands need to be flexible and elastic. Polymer, due to their amazing ability to be engineered to have a wide variety of properties, can exhibit extreme flexibility. In this video, we will expand on this notion and look at other factors that can play a role in material selection. When I was in college, I did all my work on a 486 computer. That's what you see on the screen right now. Looks old, doesn't it? The CPU in a computer, or the central processing unit, is responsible for carrying out all tasks and telling all the other components in the computer what to do. As a consequence, the CPU generates a lot of heat, and this heat needs to be taken away. This is done by using a heat sink. The heat sink sits on the CPU and conducts the heat away into the air. A fan blows on the heat sink to increase the heat transfer, just like when you blow on hot food to cool it down. When selecting a material to make the heat sink from, we need a material that is conductive. Back in 1988, aluminum was fully capable of conducting the heat away from a 486 CPU. The thermal conductivity of aluminum is 205 watts per meter Kelvin. The thermal conductivity is how well a material conducts heat. The higher the value, the better the material is at conducting heat. Another thing I want you to notice is the number of fins in the heat sink. You can count them. There are 45. The more area there is, or the more fins, the better the heat is conducted away. Current computers need significantly more cooling, much more than just a small heat sink and a fan. Many desktops are liquid cooled and have a mini radiator like you see in an automobile. The heat sink itself is now made from copper, which has a higher thermal conductivity than aluminum. If you look at the number of fins, it is really hard to see the individual fins. There are so many. The more fins there are, the more heat can be transferred. In this case, choosing the correct material based on its thermal conductivity was key to the design performance. Aluminum would not have been able to do the job in this case. Let's take a look at eating utensils. Many different materials can be used to make them. For example, silver, plastic, and stainless steel. Why is each material selected? What are the advantages and disadvantages? So why would you want to make silverware out of silver? Obviously, it's common. That's where it's got its name. But what's so special about silver? Well, silver is a metal and therefore is strong and can withstand the heat of cooking. But it's even more special than that. It has antibacterial properties. Bacteria aren't able to survive on it. You don't need to sterilize silver like you do plastic and stainless steel. Minimal soap and water is enough to do the job. So that's really good. Why don't we make all silverware out of silver? Right, it's expensive. Well, how about plastic? What's good about plastic? Well, it's not expensive and it's easy to manufacture. Beyond that, there isn't really anything good about plastic. It doesn't handle heat well, and it can be toxic. It may contain BPA or phthalates that can cause many health issues. It is also disposable and not biodegradable, so it's not good for the planet. All right, what about stainless steel then? It's a metal and therefore strong and can handle the heat. And it's less expensive than silver. It also has the advantage of being corrosive resistant. This is why stainless steel is the material of choice nowadays for silverware. So things that we consider when selecting materials for these eating utensils were material properties, cost, manufacturability, how long will it last, how will it affect the environment. For example, is it toxic? And how will the environment affect it? Will it corrode? So another thing to consider is the availability of the material. Can you get it? So when selecting materials, all these things are important and come into play.